Hello, everyone. This is the third of the series on building AI first organizations, agents, AI strategy, and governance. I am Murtaza Chaudhary, and I lead Agentic AI driven modernization at AWS. My work focuses on helping organizations move from legacy systems to modern AI powered platforms safely and pragmatically. This is the third of a four-part series on how enterprises are building AI first organizations. In the last two episodes, we discussed modernization with Gen AI and responsible AI in practice. I hope you enjoyed them. Today, we'll explore one of the most exciting frontiers in AI, the rise of agentic systems, software that can reason, act, and learn on its own. We have one more episode after this about leadership with AI. Here's where we are headed today. First, we'll define what agentic AI actually is. Not the hype, but the core concepts that matter for builders and leaders. Then we'll compare agentic systems to traditional automation because understanding that shift is key to understanding why this moment is so important. After that, we'll break apart the building blocks, reasoning loops, memory, tools, orchestration, the components that turn an LLM into an autonomous worker. We'll look at real enterprise use cases across development, customer experience to ground ideas in reality. And finally, we'll explore governance, safety, and best practices that help teams adopt agentic systems responsibly and effectively. By the end, I'm hoping you'll have a clear, practical understanding of how agentic AI works, where it's headed, and what it means for product and engineering teams. Agentic AI systems don't just answer questions, they decide what to do next. They perceive context, reason about it, plan a sequence of actions, and execute those actions through tools or APIs. Think of them as digital teammates who can handle a task end to end, gathering information, making decisions, trying strategies, and learning from the outcome. This is a major shift from traditional automation. Instead of following a script, agentic systems pursue goals and adjust their approach when the environment changes. It's the difference between, say, a calculator and a junior analyst. To understand why agentic AI is such a breakthrough, we need to compare it with what enterprises have relied on for decades: traditional automation. Automation is built on predefined rules. You tell the system exactly what to do and in what order and under what conditions. It's powerful for repetitive, predictable tasks, but it breaks the moment the problem changes. Agentic systems are fundamentally different. Instead of following a script, they reason about what to do next. They can tackle open ended or ambiguous problems because they're not limited to a fixed workflow. Another difference is adaptivity. Automation waits for a trigger. Agents instead pursue goals. They can break tasks down, choose tools, evaluate results, and iterate until they reach an outcome. This is why agentic AI isn't just better automation, it's a new computing paradigm. It shifts software from being reactive to being proactive, from instruction driven to goal driven. It's helpful to zoom out and look at the broader arc of how we got here. In the 1980s and 1990s, we had expert systems. rule based software that tried to capture human logic. They worked in narrow domains but collapsed when anything unexpected happened. Then came workflow automation and RPA in the 2010s. These systems accelerated business processes, but they were still linear, fragile, and dependent on perfect inputs. The real breakthrough arrived with LLMs, systems that can understand language, reason through ambiguity, and generalize far beyond their training data. And now we are entering the agentic era. Agents don't just respond, they plan, act, and improve over time. They can use tools, call APIs, break tasks down, and coordinate with other agents. The shift moves us from automation that follows rules to intelligence that pursues goals. Every agent, no matter how advanced, is built around five core principles. First, they perceive. They take in context from text, systems, or environments. Then they reason, choosing an approach rather than following a script. Then they plan, breaking a goal into sequence steps and selecting the right tools to achieve it. They act, meaning they call APIs, write code, search, retrieve data, or execute workflows. And finally, they reflect. This is what makes agents very powerful. They evaluate the results of their actions and adjust their strategy. These five steps from the intelligence loop that differentiates an agent from a standard model or an automation script. Agentic systems don't behave like traditional software. Traditional automation follows a flowchart. Once you define the branches, that's all it can do. Agents operate in a reasoning loop. They start by observing the environment, the input, the context, the state. Then they think, reasoning through the best approach, evaluating constraints, and considering alternatives. Next, they plan. This is where agents break down big goals into small steps and choose the right tools for each one. Then they act, calling APIs, generating code, orchestrating workflows, or gathering new information. And finally, they reflect. This is the key difference. Agents evaluate whether the actions worked, what failed, and what needs adjusting. This cycle continues until the goal is achieved. It's what gives agents resilience, adaptivity, and initiative. Let's look under the hood at how an agent is actually constructed. At the center, you have the reasoning engine, usually an LLM that interprets instructions, reasons about goals, and makes decisions. Surrounding this is the memory layer. This can include short term context, long term knowledge, or episodic memory so the agent remembers past interactions or tasks. Then there's the tool layer. This is critical. Agents become useful only when they can take action, call APIs, execute searches, write code, query databases, use services, etc. This is how agents move from thinking to doing. On top of all this sits the controller or policy layer, which enforces permissions, constraints, guardrails, and safety rules. It determines what the agent is allowed to do and monitors compliance. Finally, there's a built in feedback loop so the agent can evaluate whether its actions worked and correct its strategies. We are hitting a perfect storm that makes agentic AI possible today. First, LLMs have reached a reasoning threshold where they can make decisions, not just predict text. That single shift unlocks autonomy. Second, the modern API ecosystem has exploded. Everything from services to tools is now accessible programmatically. Agents finally have hands to take action. Third, inference cost and latency have dropped dramatically, making continuous reasoning loops feasible at scale. And finally, enterprises are hitting the ceiling of traditional automation. They want systems that adapt, not just follow scripts. All these forces converge to make agentic systems not only viable but inevitable. Agentic systems fall into three broad categories: reactive agents that simply respond to inputs, reflective agents that maintain memory and plan their next steps, and fully autonomous agents that pursue goals, self correct, and orchestrate workflows using tools and APIs. Most enterprises today sit in the reflective category, but we are rapidly moving toward autonomous agents as reasoning, quality, tooling, and governance frameworks mature. To understand what agentic systems can do, let's break it down into four foundational capabilities. First is planning. This is where agents take a goal and break it into a sequence of steps. Unlike traditional automation, planning isn't predefined. The agent evaluates options, constraints, and expected outcomes, very similar to how a human architect or a project manager thinks through a task. Second is perception. Agents must interpret the environment, whether that environment is code, logs, documents, APIs, or real world signals. Third is action. This is where agents actually execute, running commands, modifying code, updating infrastructure, opening pull requests, triggering CI pipelines, all autonomously. And finally, learning. Agents improve over time. They adapt based on feedback loops, test results, user corrections, or reward signals. This makes the system better with every interaction, much closer to, say, an apprentice developer growing through experience. At the heart of every agentic system is a simple but powerful loop. First, the agent observes. It pulls data from tools, APIs, documents, logs, or user instructions. This is where it builds a mental model of the state of the world. Next, it reasons. This is where the LLM is deciding what to do next, plan a step, or evaluate trade offs, or choose among alternatives. In a traditional system, this logic would be hard coded. Here, it's dynamic. Then the agent acts. It calls an API, writes code, queries a database, etc. This is where value is created. Finally, it reflects, where it checks whether the action succeeded, it updates its memory, and adjusts its plan. When enterprises build agentic systems, they typically land in one of three architectural patterns. The first is the single agent model. This is a single, highly capable agent that handles an end to end workflow. For example, code refactoring or customer support triage. It's simple, easier to govern, and great for well bounded tasks. The second pattern is multi agent systems. Think of this like a team. One agent plans, another does API calls, another performs validation. Each agent has specialized skills and they collaborate through messages. This mirrors organizational design and becomes incredibly powerful for complex workloads like end to end cloud migration or supply chain optimization. Finally, you have human in the loop agents. In regulated organizations, they are very essential. The agent does most of the work but escalates when needed for approval, risk checks, or ambiguous decisions. This keeps human in control while still benefiting from automation. Enterprises often ask, where do agents actually live in our stack. Agents sit above existing systems, whether it's ERP, CRM, CI/CD, cloud services, or data warehouses. They don't replace these systems, they orchestrate them. The agent consumes enterprise data, logs, policies, documents, API outputs, and uses that understanding to choose the next best action. The actual doing happens through the APIs and tools. In other words, the agents think, but the tools act. And critically, humans still play a role. Agents escalate for approvals, request clarification, or hand off tasks that require human judgment. If you think of your enterprise stack as layers, agents form a new intelligent orchestration layer that adapts to context and goals instead of following rigid flows. Let's start with the simplest model, the single agent pattern. This is one highly capable agent that owns an entire workflow end to end. It observes context, reasons about what to do next, executes actions through APIs or tools, and reflects on the outcome. Single agent systems are best when the domain is complex enough to require reasoning, but not so complex that coordination across multiple agents is needed. They shine in bounded tasks like code refactoring, customer support triage, or knowledge retrieval. From a governance standpoint, they're easier to secure, easier to audit, and faster to deploy. And most enterprises start here. They master single agent systems and then expand to multi agent architectures once the workloads and orchestration patterns grow more demanding. As workflows grow in complexity, enterprises shift from single agent systems to multi agent collaboration. In multi agent setups, each agent has a distinct role: planning, executing, validating, researching, or reviewing. The magic comes from their coordination. They communicate through messages or shared memory, handing work off in a way that mirrors real teams. This architecture is powerful for large multi step tasks, cloud modernization, supply chain decisions, end to end risk reviews, or multi stage code generation. Not every workflow should be fully autonomous, and enterprises know this. Human in the loop agents strike that perfect balance between automation and accountability. In this model, the agent does the heavy lifting, gathering context, analyzing the situation, proposing next steps, drafting actions. But the human stays in control for the final decision. They approve changes, resolve ambiguity, or intervene when the agent hits uncertainty or risk. This pattern is essential for regulated industries like finance, healthcare, government, and large enterprises with strict compliance requirements. Tool use is where agents stop being chatbots and start being workers. A language model on its own can understand and reason, but it can't actually do anything. Tools and APIs give agents the ability to take action, running a search query or calling a service or writing code, for example. Modern agents reason not only about what to do, but which tool to use and in what sequence. This makes tool use the foundation of real autonomy. The richer the tool ecosystem, the more powerful and versatile the agent becomes. Memory is what separates simple LLM interactions from true agentic behavior. Agents operate with three major forms of memory. Short term memory is working context, the equivalent of what a human keeps in mind while solving a problem. Long term memory stores knowledge that persists across tasks or sessions. This could be customer data, system configurations, prior analysis, or learned patterns. Then there's episodic memory, which captures the history of actions and their outcomes. This gives agents the ability to reflect, learn, and improve their strategies over time. Now that we have seen how agents reason with memory, The next piece is planning. Agent planning is what turns intelligence into action. When an agent receives a high level objective, for example, launch a new application or prepare for a compliance audit, it doesn't just take a single action. Instead, it decomposes that objective into a sequence of smaller interdependent tasks, checking prerequisites, gathering inputs, validating constraints, executing steps in the correct order, and verifying outcomes. Now that we have looked at how agents retrieve context and memory, the next part of the loop is action execution. This is where agent takes its internal reasoning and turns it into something real, a database query, an API call, or a workflow step. A mature agent doesn't just act, it chooses among multiple action paths using branching logic. If an API fails or data looks suspicious, a guardrail should trigger a fallback. In enterprise settings, this is where most of the governance is needed. When an agent decides to execute an action, it isn't magic, it's a repeatable sequence. The first step is selecting the right tool. Next, the agent prepares the input. Then it calls the tool. Finally, the agent processes the output. It evaluates whether the result satisfies the objective, whether additional steps are needed, and whether the outcome should be written back to memory. This post processing step is what allows the agent to adapt, branch paths, or escalate when needed. The key point: agents aren't doing monolithic tasks, they're executing chains of small, deliberate, tool powered steps, just like an experienced operator. A core differentiator of agentic systems is their ability to reflect on their own actions. After every step, whether it's tool invocation, a data retrieval, or a computation, the agent evaluates the outcome. It checks: did I get what I expected? Is the result valid? Do I have enough information to move forward? This self evaluation is critical in enterprise environments because it lets agents catch inconsistencies, hallucinations, or incomplete data before they propagate into downstream actions. Because of reflections, agents can dynamically choose to retry an action, revise their plan, request missing inputs, or escalate to a human reviewer. Even the most advanced agentic systems need human oversight, especially in enterprise. Human in the loop control means the agent handles the bulk of the world, but the human operator evaluates specific moments when stakes are high, data is ambiguous, or a decision crosses into risk or compliance territory. A mature agent doesn't wait for a failure to occur. It proactively escalates when its confidence drops, when inputs conflict, or when the situation falls outside its training distribution. Once agents begin executing real actions in enterprise systems, safety becomes non negotiable. Guardrails are the enforcement layer that defines what an agent can and cannot do. These include access controls, policy constraints, red lines, permissions, and execution boundaries. A good guardrail system operates at three levels: before execution, during execution, and after execution. Guardrails prevent actions like deleting resources, modifying financial records, or escalating privileges without authorization. One of the biggest shifts in the agentic world is realizing that agents need a full testing and validation discipline, not just prompt tuning. Agents operate like distributed systems. They invoke tools, manage state, react to failures, and make context dependent decisions. That means we need full validation frameworks, reasoning tests to ensure decisions make sense, safety tests to ensure actions stay within the guardrails, and adversarial tests to evaluate robustness against malformed inputs. We also simulate API failures, latency spikes, empty responses, permission errors, all the scenarios an agent is certain to encounter in a real enterprise. And regression testing becomes critical because agents evolve over time as prompts, tools, and memory change. Without testing, performance drifts or breaks silently. This step is what separates toy demos from production grade agentic systems. Now, let's talk about one of the most important operational risks with agentic systems: agent drift. Unlike traditional automation, agentic systems are not static. They evolve as they reason, retrieve new context, or adjust planning strategies. Over time, they may start deviating from the constraints or goals we originally set for them. This can be subtle. Maybe they start choosing slower paths, overusing certain tools, hallucinating credentials, or making decisions with incorrect assumptions. Or it can be major, like making changes to code bases or workflows that were not approved. That's why drift detection is essential. This means actively monitoring behavioral anomalies, unexpected tool usage patterns, and deviations from expected reasoning steps. We pair automated drift signals with human checkpoints to ensure agents remain aligned, safe, and predictable, especially in enterprise or regulated environments. Drift is normal, managing it is the real maturity milestone. As soon as agents begin making decisions and triggering actions, observability becomes one of the most important capabilities. With traditional software, we log inputs and output. With agents, we need to log everything: the reasoning chain, the tool selected, the confidence level, the branching logic, and the final outcome. Telemetry gives us full visibility into how the agent reached its decisions. This is essential not just for debugging, but for safety, compliance, and trust. Observability also helps us optimize agent performance. We can track latency spikes, tool failures, or cases where the agent loops unnecessarily. For enterprises, auditability isn't optional. So, production agents must have deep, transparent, end to end observability built in from day one. Scaling agents across an enterprise is not just about adding more compute. It requires standardizing how agents reason, how they access tools, how memory is structured, and how governance is enforced. The goal is coherence: a shared tool registry, shared policy engine, shared memory schemas. It gives you reusable agent templates that can be deployed rapidly across departments. You also need infrastructure that works across hybrid and multi cloud environments because agents will interact with data and systems everywhere. And finally, all your observability, drift detection, safety checks, and approval workflows must scale right alongside usage. This is where we are heading. The long term vision for agentic AI isn't a single agent sitting in one product, it's a network of specialized agents distributed across the organization, each with unique capabilities working together to solve complex cross functional problems. Think of it like a digital workforce. Just as teams coordinate in a company, agents will collaborate across planning, execution, monitoring, and optimization. One agent may analyze data, another may trigger workflows, another may handle exceptions. This is what systems that don't just automate tasks but drive outcomes. This is how enterprises will scale intelligence. And this vision requires careful governance. Let's look at a real enterprise use of agentic systems to automate customer support. When a customer sends a message via chat or email, a planner agent classifies the intent: billing issue, refund question, product troubleshooting, cancellation, etc. Based on the problem type, it routes to one or more worker agents. One that retrieve knowledge from internal docs, one checks account data, another executes automated workflows like issuing refunds or resetting credentials. Before anything goes back to the user, a reviewer agent evaluates accuracy, safety, and compliance, ensuring no confidential data or unsafe actions slip through. Human only step in for high risk cases, policy exceptions, or ambiguous intent. This case study comes from a cloud operations team responsible for a set of latency sensitive services. Their agent observes metrics, CPU spikes, saturation, queue depth, as well as logs and alert streams. When something deviates from normal patterns, the agent triggers a diagnostic workflow. It pulls the relevant runbook, inspects log around the anomaly window, checks the state of dependent services, and generates a summary of what's likely happening. From there, the agent proposes a remediation action: restart maybe a failing pod, scale out a noisy neighbor, or drain connections from a problematic node. Only after validation does the agent execute a safe and reversible action. Human engineers get looped in only if the risk is high, the confidence is low, or if the policy requires approval. This shifts DevOps from reactive firefighting to proactive automated incident response, reducing toil and improving reliability. When we shift from standard AI to agentic systems, governance must evolve. Traditional AI governance focuses on datasets, model training, and periodic review. But with agents which can reason, take actions, and call tools, we need continuous dynamic oversight. We start with a policy layer that defines what agents may or may not do, which APIs they can call, which systems they may access, and what constitutes a high risk action. On top of that, we add guardrails, constraints that automatically enforce limits. For example, never issue refunds above a certain limit without approval, or never delete resources without verification. Next, we need real time execution monitoring to detect anomalies or unsafe behavior. This prevents runaway loops or unexpected actions. Every decision must generate audit logs so that teams can trace exactly why an agent did something, essential for compliance heavy industries. And finally, we preserve human oversight. Humans remain the ultimate backstop for exceptional cases, sensitive actions, or ambiguous situations. Once you deploy agents, evaluation becomes mission critical. Unlike traditional models that produce a single output, agents must perform multi step reasoning, take actions, and interact with tools, so evaluation must go beyond accuracy. We measure correctness by verifying that actions and outcomes align with goals, constraints, and policy. Efficiency evaluates latency, number of tool calls, and compute costs, crucial for production workloads. Safety ensures the agent never violates compliance boundaries, performs disallowed actions, or produces harmful outputs. And robustness focuses on edge cases, ambiguous inputs, noisy environments, partial failures, or tool outages. The most successful teams create regression test suites for agents, just like they would do for software. So the agent does not get worse as it learns or evolves. Agentic systems bring powerful new capabilities, but also new categories of risk. The first risk is hallucination loops. Second is unsafe tool calls. We also see risks like runaway tasks where agents escalate excessively, retry endlessly, or trigger unexpected cascades. Finally, there are data risks. To mitigate these, we establish strong guardrails, enforce least privilege, implement validation layers, and use human in the loop for anything that is high risk. And for reliability, we wrap agents with rate limits, timeouts, or circuit breakers to ensure that errors don't propagate. Here's the blueprint most enterprise teams follow when building agentic systems. Step one is defining the business outcome. We don't start with architecture, we start with the decision or workflow we want the agent to own. We identify constraints, acceptable actions, and what good looks like. Next, we map the tools, data, and APIs that the agent needs. This stage is critical because most agent failures happen due to unclear tool boundaries or missing permissions. Then, we choose the right architecture, single agent for small workflows or multi agent when tasks need specialization or robustness. Here, we also design memory, retrieval, and reasoning patterns. Once the structure is in place, we layer in guardrails like action filters or policy enforcement, safety verifications, and human oversight for high risk actions. And finally, we continuously evaluate, test, and iterate using regression suites and real world edge cases because agent systems evolve and their testing must evolve with them. Once we have an agentic system blueprint, the next step is making it enterprise ready. First is security and access control. Agents must operate with extremely narrow permissions. No agent should have uh, access to uh, customer data or privileged systems. Identity propagation and tool scope permissions are essential. Next is auditability. Every action an agent takes must be traceable. If a regulator, security team, or customer asks why something happened, we must be able to replay the reasoning chain and tool actions. Reliability is also critical. Agents must survive network failures, tool timeouts, stale memory, or unexpected user input. Mechanisms like retries, fallbacks, and circuit breakers make them durable. Then comes observability. We need deep visibility into metrics, logs, traces, and memory states to debug, tune, and govern agents. Lastly, we integrate compliance, embedding organizational policy and regulatory requirements directly into agent guardrails and approval flows. As powerful as today's agentic systems are, we are still early. The next wave will be driven by multi agent collaboration. Agents won't operate alone. They will coordinate like digital teams, negotiating plans, cross checking steps, and dividing work dynamically. We'll also see the rise of persistent agents that work across long time horizons, like a supply chain optimization agent that continuously forecasts, adjusts, and improves operations over weeks. Multimodal agents, they will interpret logs, charts, documents, dashboards, images, and voice, providing a unified layer of intelligence across systems. Another major shift is self optimizing agents. These systems will refine their own strategies, update their reasoning templates, and learn from failure patterns. And finally, enterprises will build an agent mesh, a distributed layer of interoperable agents integrated across business units, systems, and workflows. This becomes a new organizational operating system. The direction of travel is clear, from isolated agents to collaborative teams to enterprise wide, always on autonomous intelligence. To wrap up, there are three things I hope you carry forward from today. First, agentic systems represent a fundamental leap in automation. They don't just execute instructions, they reason, orchestrate tools, collaborate, and adapt. This opens the door to automating workflows that were previously impossible. Second, success in the enterprise requires discipline, guardrails, security, observability, and compliance. The most advanced agentic systems are the safest ones. Third, the future is not about single agents. It's about network of agents working alongside humans, collaborating across systems and forming a new operational layer for the business. Agentic AI is not just an evolution of automation. It's the beginning of a new organizational capability. Well, that's all I had for today. Thank you for joining me. I would love to hear your thoughts, questions, or even challenges. Let's keep this a real conversation.